towards a unified Faculty of Information Technology. Jyväskylä has been known as a school city and even as the Athens of Finland since the mid-1800s. This reputation has carried far and turned the city into a dynamic university town. In a small inland city, the university has had to seek new areas and continuously develop itself in order to remain vital. The story of the Faculty of Information Technology begins with the arrival of computer science education in Jyväskylä. The city had already been a pioneer in education, and the same was true for computing. In April 1964, the Jyväskylä Kauppallisuura Foundation wrote to the Finnish Computer Society, stating that it could fund 2 or 3 professorships, since future business life would increasingly require computer expertise. 2 developments lay behind this idea: the national debate about establishing new schools of economics, and the need to integrate computer science into higher education. These led to the proposal to add economic sciences to the Jyväskylä College of Education and create a professorship focused on computer science. This became reality in 1967 thanks to the foundation's donation, Birth Pains and Process. In the mid-1990s, a wide-ranging discussion about establishing a new faculty began. The computer science department had been left alone in the Faculty of Social Sciences after economics became an independent unit, and there was significant overlap between computer science, mathematics, and software production programs. This fragmentation weakened Jyväskylä's national profile. Under the leadership of Professors Kalle Liitinen and Pekka Niittänmäki, the process moved forward, though resistance was initially strong. There were fears that the new faculty would be either too large or too small. Students, especially the student association Dumpy, were skeptical and worried that the business-oriented track might disappear. Even the name of the proposed department caused disputes, particularly over including the word mathematics. Proposals ranged from building the new department solely around computer science to dissolving the department and moving its natural science components to the Faculty of Mathematics and Science. In 1997, the University Board's development meeting produced a concrete proposal for the Faculty of Mathematics and Information Technology, which was soon renamed the Faculty of Information Technology and Mathematics. It was to consist of 4 departments: mathematics, applied mathematics and computer engineering, computer science and information systems, and statistics. Statistics was included because otherwise it would have been left isolated in an unfamiliar environment. The biggest challenge was deciding where to draw the line, which departments and subjects to include. The computer science department had strong links to both economics and computer engineering, while the mathematics department did not want to separate applied mathematics from general mathematics or from statistics. If all had been included, the new faculty would have covered almost half the university. The faculty is born the Agora era. The process stalled for a while, but external pressures pushed it forward. The new faculty was tied to a major construction project, and around the same time, news spread that Nokia was planning to relocate operations to Jyväskylä. This created the impression that if the faculty was established, a new building and perhaps Nokia would follow. In 1998, final decisions were made. The new faculty would include the entire Department of Computer Science and Information Systems, as well as the Computer Engineering Unit split from the Department of Mathematics as its own department. Applied Mathematics remained within Mathematics. A third unit, the Information Technology Research Institute, T2, joined as a research institute without teaching duties. Professor Kalle Liitinen was appointed the first dean and the Faculty of Information Technology was born. At the same time, Nokia began construction by Lake Jyväskylä, and between 1998 and 2000, the Matalaniemi campus was transformed. Three Nokia buildings rose on the lakeshore, and next to them a new faculty building was completed. Initially called the Human Technology Center, it was later named Agora. The faculty moved in at the end of August 2000. Agora also became home to companies and parts of the Department of Psychology, forming the Psycho Center complex, which aimed to bring together human sciences and technology. A new era. At its founding, Jyväskylä's Faculty of Information Technology was the only one of its kind in Finland. It continued the city's long tradition as a pioneer in education and computer science. During its first years, operations stabilized and the interface between computer engineering and computer science became clearer. Software engineering remained a joint track across two departments, possibly planting the seed for future developments. The faculty's expertise expanded in many directions, from user-friendly computing and psychocenter collaboration to mobile computing. The field of information technology changes rapidly and often unpredictably, and this diversity may be the faculty's key to survival in the future. This was its situation and strength in 2005. Towards a smart and sustainable IT faculty, 2005-2025. After 2005, the Jyväskylä Faculty of Information Technology entered a new era. Artificial intelligence, cloud computing, data analytics, and cybersecurity were transforming not only the tech field, but society as a whole. The faculty responded by expanding its teaching and research while strengthening interdisciplinary collaboration within the university and internationally. In 2025, a strong and multifaceted faculty. By 2025, the Jyväskylä IT faculty has grown into Finland's only faculty combining computer science, information technology, and human sciences in such a comprehensive way. Agora remains the central hub where research, education, and industry collaboration meet. The faculty's strength lies in its ability to adapt to rapidly changing technologies and societal needs, from AI and data-driven solutions to sustainable and human-centered innovation. Jyväskylä faculty continues the city's long tradition of combining education, research, and innovation to prepare students for the technological and ethical challenges of the future.
Jyväskylä, IT Faculty, 2026-2040, a story from the future. 2026, first steps into human-AI symbiosis. In the corridors of Agora, a new energy flowed. Students no longer just coded for computers, but collaborated with symbiotic AI assistants. These AI classmates suggested code improvements, analyzed data streams, and even proposed research topics.
It's like AI is our teacher, yet our decisions still guide it.
The teaching rhythm had changed. Theory and practice were personalized for each student with the help of AI. Research focused on human-machine collaboration, how AI could enhance creativity, decision-making, and social skills. 2030, digital cities and sustainable development. By 2030, Agora Labs took on a new mission. Jyväskylä aimed to be Europe's smartest and most sustainable city. The faculty collaborated with the city and companies to develop IoT networks that managed traffic, energy, and water in real time.
The test city was our playground.
Education emphasized green IT and research innovations, included carbon-neutral data centers and smart energy systems, blending IT and environmental science seamlessly. 2040, symbiotic human-machine communities. By 2040, Agora had transformed into a fully intelligent campus. Learning and research happened as much in virtual labs as in physical spaces. Students carried smart clothing and AR glasses that monitored the environment, AI suggestions, and their own learning patterns. A day in 2040, Mia at Jyväskylä IT faculty. Mia woke up to the gentle buzz of her AI assistant, who had already reviewed her sleep patterns, optimized her morning routine, and suggested a personalized breakfast. Today, she would head to Agora, though head was relative, since she could join part of her classes in a virtual lab while sipping coffee at home. Walking through the historic corridors of Agora, she passed holographic projections of ongoing research, autonomous drones mapping local forests, IoT devices optimizing city traffic, and a team testing AI-driven healthcare simulations. Mia smiled, feeling part of a living, breathing ecosystem where human and machine intelligence work. In the classroom, students wore AR glasses that overlaid complex neural network visualizations directly onto their lab benches. Mia's project today, designing AI companions for elderly care, helping humans live more independently while preserving emotional connection. After lunch in the Agora Commons, where virtual and physical spaces blended seamlessly, Mia joined a global video lab meeting. Her teammates were from Brazil, Japan, and Kenya, and they collaborated in real time on a sustainable energy AI system for smart cities. Cultural differences enriched the conversation, and AI moderators helped translate nuances instantly. As the sun set over the Jyväskylä shoreline, Mia reflected on her day. She was not just learning technology, she was shaping a future where humans and machines coexisted in harmony, solving real-world problems with creativity, empathy, and intelligence. She smiled at the thought. In 2040, the world felt closer, smarter, and kinder. And she was at the heart of it, at Jyväskylä ITFaculty, a place where technology and humanity walk hand in hand.
Faculty of Information Technology, 3 Visions of the Future After 2025 by 3 Separate AI Program. A Vision of DeepSeek by Saga. In 2030, the faculty's teaching focuses on how to integrate AI into everything. Studies include ethical AI, quantum computing, and digital sustainability. At this stage, biology enters the picture primarily as inspiration. We learn from the intelligence of octopuses and bee swarms and use them as models to create more efficient algorithms and robots. Imagine a robot learning to move like a gecko lizard, climbing walls. This is bio-inspired design. By 2040, things get even more interesting. It's no longer just about imitation. Biological and digital systems begin to be physically combined. The faculty's research focuses on biohybrid systems. Imagine a sensor network in a forest that isn't just circuits and antennas, but instead utilizes the fungal mycelium itself or plants' reactions to pollution to gather information. Or that computational tasks are performed not with circuits, but with lab-grown nerve cells. This would be neuromorphic computing, brain-like computing. This is the stage where Jyväskylä's strong expertise in psychology and biology merges with IT in a completely new way. The psychocenter becomes the biopsychocenter. By 2050, the difference between natural and artificial intelligence is hard to see. This is the era of symbiotic intelligence. The Faculty of IT has become a place where not only coding is taught, but deep philosophical questions are pondered. What is a living, intelligent system? What rights does it have? Research focuses on treating the entire ecosystem, like Lake Jyväskylä and its organisms, as an intelligent, self-regulating system with which we are in constant interaction. A robot is no longer just a metal frame, it may be partly composed of biological material that self-repairs. AI learning models are designed not only by engineers but also by biologists and philosophers. The core of this entire development is Jyväskylä's strength, multidisciplinarity. Jyväskylä already has strong traditions of combining humanities, natural sciences, and technology. The future Faculty of IT is not just a faculty of computers, but a faculty of living and artificial intelligence. It is a place where coders, biologists, philosophers, and psychologists invent the future together. And this will make Jyväskylä one of the world's most exciting and important centers of expertise in the development of future technology. A Vision of Grok by Lumi, the role of biology in robotics and AI before 2030. Digital integration and the rise of AI. During this time, the Faculty of IT evolves as a unified entity, responding to the global digital transformation. AI investments grow by 9% annually, and Finland's focus is on sustainable digitalization. The faculty expands its industry collaboration, and the student population grows by 10 to 15% due to hybrid models. Teaching shifts to a digital hybrid model where VRR replaces some lectures. The role of biology begins to show as research into bird brains inspires lightweight, energy-efficient AI models for drones and swarm intelligence for distributed systems. Key teaching topics: machine learning and ethical AI, data analytics, cybersecurity, digital well-being, and introductory bioelectronics. Key research areas: sustainable IT and green computing, AI applications in education and healthcare, early-stage quantum programming, and pioneering bio-AI based on animal models. Years 2030 to 2040, quantum, sustainable ecosystem, and biohybrid innovations. The quantum computing breakthrough makes JYU a quantum center, in collaboration with VTT. The climate crisis accelerates, and sustainability is central. The student population grows by 20%, and the integration of bio and nanotechnology with IT strengthens. The distributed intelligence of octopuses inspires adaptive AI systems, and biohybrid robots evolve. Teaching is immersive and metaverse-based, and sustainability modules are mandatory. Key teaching topics: quantum computing and algorithms, the combination of AI and quantum, sustainable software development, ethical technology, and bioelectronics. Key research areas: quantum sustainability conflicts, bioinformatics and climate modeling with AI, integration of quantum AI and octopus-derived intelligence, and development of biohybrid robotics, the year 2050, holistic awareness, resilience, and bio-AI. The faculty is part of a global consciousness technology network where AI, quantum, and neuroscience merge. Managing the climate crisis requires resilience, and the faculty is carbon negative. The student population grows by 30%, and teaching is personalized, AI-assisted, and VR/AR-based. The role of biology culminates. Robots' skin consists of self-repairing cells, and swarm intelligence creates conscious AI networks for climate solutions. Quantum neuroscience and animal models like octopus color change develop ethical superintelligence. Key teaching topics: quantum neuroscience, sustainable quantum technology, global resilience, ethical superintelligence, and bio-AI integrations. Key research areas: universal consciousness and quantum AI, quantum simulations of the climate crisis, bio-IT, and networks simulating ecosystem resilience. A vision of 2050, ChatGPT by Kiedis. By 2050, the University of Jyväskylä's Faculty of Information Technology had gained worldwide renown. Agora was not only a physical campus but also a global virtual innovation hub. Students and researchers from all over the world worked simultaneously on projects in the same virtual laboratory. The faculty's core was human-centric technology. Artificial intelligence, robotics, and data analytics were combined with ethical decision-making and sustainable development solutions. Students designed applications that improved the quality of life, health, and safety globally. Agora remained a center where history, the present, and the future met. Old corridors, new hologram laboratories, AI students, and humanities research together formed a whole that reminded us why the Faculty of IT in Jyväskylä is unique.